Hello, Assalamualaikum warahmatullahi wabarakatuh, and good day to every one of you. Okay, so in this week, we are going to learn on how to solve a problem with second order non-homogeneous linear differential equation for a combination cases. Okay, let's say you are given a differential equation such as ay double prime plus by prime plus cy equal to fx. Okay, so for non-homogeneous, the fx can be either polynomial, trigonometry, or exponent. Okay, however, this fx can also be a combination of exponent, polynomial, or trigonometry. Okay, so for this combination, the combination can be either by addition or by multiplication. Okay, for example, let's say you are given y double prime plus y equal to 1 minus cos 2x. So, the fx in this case, we consider as a addition of polynomial and trigonometry. Okay, for example number 2, the fx is represented by a addition of exponent and exponent function. Okay, for multiplication cases, example you have y double prime plus 2y prime plus y equal to 2 cos x cos 3x. So in this case, your fx is represented by a multiplication of trigonometry and trigonometry. Okay, so for the next example, your fx is represented by a multiplication of polynomial and exponent. Okay. So now let's have a look at the example when fx consists of addition cases. Okay, so the question is, obtain the particular solution for y double prime plus y equal to 2 sine squared x with initial conditions when x equal to 0, y equal to 2, and when x equal to 0, y prime is equal to 1. Okay, so step number 1, you need to find the complementary function for the corresponding homogeneous equation. So in this case, the corresponding homogeneous equation is given by y double prime plus y equal to 0. So from the homogeneous equation, we come up with the characteristic equation of m squared plus 1 is equal to 0. So in this case, m squared equal to negative 1. So m is equal to plus minus I. Okay, so for this case we consider as a case 3 where the root is a complex number. So, in this case, alpha is equal to 0, beta is equal to 1. Okay, so from here, we know that the complementary function yc is equal to a cos x plus b sin x. Okay, so next, the next step, we need to find the particular integral yp. So, since fx is equal to 2 sine squared x, so we need to refer to the double angle identity. So in this case, we have cos 2x is equal to 1 minus 2 sine squared x. So here we have 2 sine squared x. So again, from here, 2 sine squared x is equal to 1 minus cos 2x. Okay, so now the fx is given by 1 minus cos 2x. So from here, we know it is the addition of polynomial and trigonometry. Okay, so now how to assume yp? We need to refer to this table. Okay, so your fx is given by 1 minus cos 2x. So 1 is a polynomial, so we refer to this table. So k1 is k is equal to 1. So yp is equal to c. Okay, for negative cos 2x, okay, so here you have a trigonometry k cos nx, where here n is equal to 2. So yp is equal to c sin 2x plus d cos 2x. Okay. So now you have yp is equal to c plus d cos 2x plus e sin 2x. Okay, so c represent yp for polynomial and the rest represent yp for trigonometry. Okay, so now next, you need to compare yp to the yc. Okay, here you have a cos x, but here you have d cos 2x. So yc is not equal to yp. Okay. Okay, so now we differentiate yp over x to get yp prime. So c we differentiate over x, we got 0. D cos 2x, we differentiate over x, we got negative 2d sin 2x. And e sin 2x, we differentiate over x, we got 2e cos 2x. Yp prime, we differentiate over x, we get yp double prime. So negative 2d sin 2x, when we differentiate, we got negative 4d cos 2x. 2e cos 2x, we differentiate over x, we got negative 4e sine 2x. So next, once we done with the differentiation, we need to substitute the yp double prime and yp into the given ODE. So in this case, based on the given ODE, what we have, yp double prime plus yp is equal to 1 minus cos 2x. So we just substitute accordingly. So the yp double prime is represented by negative 4d cos 2x minus 4e sine 2x, and yp is represented by c plus d cos 2x plus e sine 2x. Next, we need to further simplify the equation. So from here, negative 4d cos 2x plus d cos 2x is equal to negative 3d cos 2x. Negative 4e sine 2x plus e sine 2x is equal to negative 3e sine 2x plus c. Okay, so once we're done with the simplification, we need to do the we need to find the value for d and c. So how to find it? Sorry, we need to find the value for d, e, and c. So how to find it? We do the equating the coefficient. So for the coefficient cos 2x, negative 3d is equal to negative 1. So simplify it to get d equal to 1 over 3. So for coefficient sine 2x, negative 3e is equal to 0. Because at this side, you don't have the coefficient of sine 2x. So negative 3e is equal to 0. So e is equal to 0. So the last one, c is equal to 1. Okay, so once you get the value of c, d, and e, you just substitute back into the yp. So again, yp is equal to c plus d cos 2x, e plus e sine 2x. So c is equal to 1, d is equal to 1 over 3, and e is equal to 0. Okay, so the last part, we need to find the general solution. Okay, y is equal to yc plus yp. Okay, so yc is given by a cos x plus b sin x, and yp is given by 1 plus 1 over 3 cos 2x. Okay, so this is the general solution for the ODE. Okay, so the final step, we need to consider the initial conditions. Okay, so again, the general solution of y is given by a cos x plus b sin x plus 1 over 3 cos 2x. So the first initial condition is when x is equal to 0, y equal to 2. So you substitute into the general solution, what we have, 2 is equal to a cos 0 plus b sin 0 plus 1 over 3 cos 0. Okay, so cos 0 is equal to 1, sin 0 is equal to 0. So we simplify it, become 2 is equal to a plus 1 over 3. And then we rearrange it to solve for a. We solve for a is equal to 2 minus 1 is 1. 1 minus 1 over 3 is equal to 2 over 3. So next, we differentiate y to get y prime. So a cos x, we differentiate, we got negative a sin x. B sin x, we differentiate, we got b cos x. 1, we differentiate over x, we get 0. 1 over 3 cos 2x, we differentiate, we got negative 2 over 3 sin 2x. Next, you need to substitute the second initial conditions, which is when x is equal to 0, y prime is equal to 1. So from here, what we get is 1 is equal to, a is 2 over 3, right? So that's why here you have negative 2 over 3 sin 0 plus b cos 0 minus 2 over 3 sin 2 multiplied with 0. So here, sin 0 and sin 0 is equal to 0, and cos 0 is equal to 1. So that's why you have 1 is equal to b. Okay. So finally, you can substitute back the value of a and b into the general solution. Okay, so finally, what we have, the particular solution is given by y is equal to 2 over 3 cos x plus sin x plus 1 over 3 cos 2x. Okay, so this is your particular solution for the ODE. Okay. So now let's look at the following example in which the fx consists of multiplication cases. Okay, so this question here is, find general solution for d squared y over dx squared plus 4 dy over dx plus 4y equal to 3x exponential negative 2x. Okay, so step number 1, you need to find the complementary function for the corresponding homogeneous equation, which is given by y double prime plus 4y prime plus 4y equal to 0. Okay, so from there you come up with the quadratic equation, which is given by m squared plus 4m plus 4 equal to 0. Then you need to solve the quadratic equation by using, you might use calculator, or you can also like solve it. So now you have root is equal to -2 and -2. So this is represented by case 2 where both of the root number is same and real. So that's why your solution is given by a plus bx multiplied with exponential mx. So from there, what you have is yc is equal to a plus bx exponential -2x because m is equal to -2. Okay, so you can expand the equation to have a exponential -2x plus bx exponential -2x. Okay, so next, the step number 2, we need to find the particular integral. Okay, since fx is equal to 3x exponential -2x, so from here you can see that the fx is a multiplication of the polynomial and exponent function. Okay, so that's why now you have yp is equal to c plus dx, which is represent the yp for polynomial of 3x, and exponential -2x, which is represent yp for the exponent function. Okay, so now you can just expand your equation to have yp is equal to c exponential -2x plus dx exponential -2x. Okay, so next, you need to compare your yp with the given yc. Okay, so if you compare c exponential -2x is equal to a exponential -2x, right? So that's why we can consider yp is equal to yc. So because yp is equal to yc, you need to multiply your yp with x. So your new yp will be cx exponential -2x plus dx squared exponential -2x. And then you need to compare it back to the yc. So from here you have cx exponential -2x is equal to bx exponential -2x, right? So you consider your yp is equal to your yc. Again, we multiply yp with x. Okay, so now we have yp is equal to cx squared exponential -2x plus dx to the power of 3 exponential -2x. So now yp is no longer equal to yc. So this is the final yp. Now you want to find the value for c and d. So in order to do that, you need to differentiate yp over x 2 times. Okay, so you may use product rule to solve the differentiation. Okay, so for yp prime is given by this equation. Okay, so we simplify this equation by factorize the exponential -2x to the outside, and then this is the yp prime. So next we need to differentiate yp prime over x to get yp double prime. Okay, so again this the term can be represented by u and v. So the yp double prime is equal to this equation. Okay, so next we further simplify the equation by factorize the exponential -2x to the outside. Okay, next we can further simplify the equation because now we have -4cx minus 4cx, I got -8cx, and -6dx squared minus 6dx squared, I got -12dx squared. Okay, so next we need to substitute the yp double prime, yp prime, and yp into the given ODE. So this is the given ODE. Okay, so this equation represents yp double prime, this equation represents yp prime, and this equation represents yp. So next we rearrange the equation according to its coefficient. So here I have 1 coefficient, 2 coefficient, 3 coefficient, and 4 coefficient. So next, we can further simplify the equation because -xc plus xc is equal to 0. Here also becomes 0 and here also 0. Okay, so finally, what we have 2c exponential -2x plus 6dx exponential -2x equal to 3x exponential -2x. Okay, next, by equating the coefficient, I can find the value for c and d. Okay, for the first coefficient, which is exponential -2x, 2c is equal to 0 because at this side you don't have the coefficient of exponential -2x. So 2c equal to 0, so c is equal to 0. For the second coefficient, 6d is equal to 3. Okay, so d is equal to 1 over 2. Okay, so from here, again, yp is equal to this, and then we just substitute the value of c and d. So now I have yp is equal to 1 over 2x to the power of 3 exponential -2x. So finally, the particular solution, for the general solution y is equal to yc plus yp. Okay, so this is the general solution for the ODE.